Alright, as I promised, here is a problem very similar to number 17. 17 deals with half-life and the number will be bigger. This is a car, but the concept is the same, and that is something is diminishing or decaying with a half-life that you know the time of. Alright, so we're going to say suppose that any car loses half its value every 7 years. That might be pretty close to being accurate, so we'll just assume that that is true. Has a half-life of 7 years. So we're saying that suppose a BMW costs $44,000 new. How much is it worth after 10 years? Okay, and then how long will it take until it's worth $12,000? So these are two separate problems. First thing you have to do is you have to get a handle on the type of equation, and this is one where we'll say the value of the car. Actually, I'm going to go to use function notation because that makes a lot more sense. The value of the car based on time, okay, that's V of t, is going to be $44,000 in its original value times 1/2, because it's a half-life problem. Right up there we're telling you that it's a half-life problem. And then the variable is going to be t divided by the time it takes, which is 7 years. Okay, so that's the working equation that we'll use to solve this. And the first part then, these are going to be the easier version of this, because all we want to know is at a certain time what's the value. So I can say, alright, the value of the car after 10 years, V of t then is going to be 44,000 then times 1/2, which is then going to be raised to the, and I guess I'll use a calculator notation here, 10 divided by 7. Okay, so I'm raising 1/2 to the 10�7th power. All I need is a calculator, and I had one here a second ago. Alright, so if I say 44,000, and then I'm going to multiply that, and I can use 0.5 or you can use 1/2, whichever is easier for you. And then I'm going to raise that. Don't forget parentheses, because if I just raise it to the 10th power without a parentheses, then I'll get that answer, because we do exponents first, and then we would divide it by 7, whereas I want this to be divided first. So I'll put 10 divided by 7, close parentheses. I hit enter, and I get $16,346. Okay, so it's very, very close to $16,346. All right, you don't have to give it the answer to the last penny. Okay, the second part though is going to be one where I'm asked how long, how much time does it take until this car is worth $12,000. All right, so to do that, I'm going to actually erase the top part so you can see. All right, remember those facts, write them down. But I'm going to take, and in my calculator, I'm going to write for Y1 in my calculator, 44,000, no comma, I guess we typed it into our calculator, 44,000 then times, and I'm going to use 0.5, then caret to the parentheses, x divided by 7. Alright? So you can pause me, you can type that into your calculator, and then see if you can figure out what would be a reasonable window considering the real world situation. Alright, so think about what does X stand for, what does Y stand for in this problem, and try to think about appropriate maximum minimum values for this problem. Alright, you can pause me. Alright, pause me. Okay, and then come back. Okay, I've typed this into the calculator. Hopefully this is what you have as well. You can see that as you go along here, it jumps down a line. Just be careful, that you don't lose track of it. Don't lose track of the parentheses. But that is the equation as I've typed it in. Now I go to the window, and what I asked you to do is to think about sensible numbers there. Well, X, that's our time value, and I'm talking about buying a new car, so it doesn't make sense to go back in time. If it was a used car, maybe it would, because you could go back to when it was new at some minus time amount. But I'm going to type in 0 for that minimum value. Now, the longest you might own a car is maybe 20 years, 25 years, so I'll put in 25. But be careful, this is where you want to make sure you don't mix up your X's and Y's and then type in something like 40,000, because you're going to get a ridiculously small window then, or ridiculously large window. This is my scale, this is how often those little tick marks will be across the bottom. You can make it 0 if it confuses you, but usually make it 5 to or 10 to 20% of what that spread in values is. The Y minimum, that's the least my car could be worth. Well, it could go down to 0, I suppose. And the most it's going to be worth here is $44,000. I'm just going to make it a nice round $50,000 so I can see above it. And my scale, if I leave that at 1, that Y axis will just be thick lines too close together. So I make it every 10,000 like that. And if I go to graph, I can see there's the value of the car as it diminishes over time. Now I can trace this if I wanted to, and I can see down here when my time is at 12.5 years, the value of the car is about $12,700. I want to find out when does it get to exactly 12,000, so that was really pretty close. If I go a little bit lower, 12,106, and then now 11,791. So that's on either side of it, so it's around 13 years. To be more precise, I can do this. I can go to Y equals. I can go down here and type in 12,000. And then when I graph, that's the value line at 12,000. And I can just find out where the intersection point is by going second and then this trace button right here, the second one in on the left. And then I go to intersect. That's option number 5. So I can just scroll down and choose enter, or I can just press the number 5. And it's asking me, is this the first curve? And I can make sure, oh, that's the exponential decay curve, so I hit yes, enter. And is that the second curve? Well, it's a line, it's not really a curve, but that's what they mean. And then I say yep, and then by pressing a third time, it tells me that the Y value is at 12,000 after 13.12 years. So a little bit more than 13 years. That'd be like 13 years and what, almost a month and a half or 2 months. Okay, that's how you do it. Good luck.